Have you ever wondered why the Saturn V rocket had stages? You're not alone, space enthusiasts. The Saturn V rocket, an iconic symbol of space exploration, was not just a single piece of technology. It was a multi-stage rocket, each stage playing a pivotal role in the Apollo missions. This giant leap in engineering has sparked curiosity for decades. But why stages? Not a single continuous rocket? So let's delve into the fascinating world of rocket science to understand why the Saturn V rocket had stages. The Saturn V rocket was a three-stage rocket. It's a marvel of engineering that took humans to the moon. Our journey begins with the first stage, the SIC. This powerhouse provided the initial thrust, a force so powerful it could lift the entire weight of the Saturn V rocket, all 6 million pounds of it, off of the ground. 5 F1 engines worked together, burning for about 2.5 minutes, propelling the rocket to an altitude of about 42 miles. Once the SIC stage had done its job, it was time for the second stage, the S2, to take over. The S2, powered by 5 J2 engines, was a little less powerful but more efficient, and it took over after the first stage ran out of fuel. It carried the rocket to an altitude of about 115 miles, reaching a speed of more than 15,000 miles per hour, close to Earth's escape velocity. The third stage, the S4B, entered the scene. This stage had just one J2 engine, but it was tasked with two crucial roles. Firstly, it propelled the Apollo spacecraft into Earth orbit. Then, after a short pause, it reignited, providing the final push to send the spacecraft on its trajectory to the moon. Each stage had a specific role to play a crucial part in the journey of the Saturn V rocket. Now, you might be wondering, why did the Saturn V rocket need these stages? Well, the principle of rocket staging is a clever solution to a complex problem. Rockets, by nature, need to be light, yet they also need to carry enough fuel to reach incredible speeds and altitudes. Stages of Saturn V were like a series of mini rockets stacked on top of each other. Each stage had its own engine and fuel. When a stage used up its fuel, it was jettisoned, shedding unnecessary weight and allowing the rocket to climb higher and faster. This process repeated until the final stage was ignited, propelling the astronauts towards the moon. Staging, therefore, is a perfect balance of weight and power, a dance of physics and engineering that allows us to reach beyond our world. So, the stages of the Saturn V rocket were not just a design choice, but a necessity for the successful moon missions. It's the brilliance of engineering that led humans to step on a world beyond our own.